Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a problem on specific speed of turbine. In our last lecture, we have discussed about the equation of specific speed of turbine. Now we'll see the problem on specific speed of turbine. So here I have taken a question of a Pelton wheel develops 8000 kilowatt. So the question given under the category of Pelton wheel, which develops 8000 kilowatt of power under a net head of 130 meter at a speed of 200 rpm. Assuming that the coefficient of velocity for the nozzle is 0.98, hydraulic efficiency is given 87%, speed ratio is given 0.46, and the jet diameter to wheel diameter ratio is given 1/9. We determine the discharge required, diameter of the wheel, and diameter of the diameter, and number of jets required, and specific speed. So we need to calculate these many things. Along with that, the mechanical efficiency is given 75%. Okay, so these are the data given for this problem, and we need to find out discharge, diameter of the wheel, and the diameter of the jet, and the number of jets, and specific speed. So first of all, we'll identify what are the data are given, and we will solve the problem here. So in the solution, let me write first what are the data are given in this. So first one, we can see the power developed. So here I can write P, power developed, equal to, this is 8000 kilowatt. Next one, under a net head of, that is net head is nothing but we can mark it as H. This is given 130 meter. Next, speed is given. Speed of the turbine is given. This is 200 rpm. Assuming that the coefficient of velocity, so that is CV, coefficient of velocity is nothing but 0.98, and hydraulic efficiency is given. Hydraulic efficiency we can write in this notation, eta H. So this is 87%, and this one we can write 0.87. Next is given speed ratio, this is 0.46, and yeah, so speed ratio we can write. Actually, speed ratio, the formula is speed ratio equal to, this one we can write phi speed ratio equal to, the formula is like u1 by root over of 2gh. Okay, so speed ratio value is given, that is 0.46, and the diameter to jet diameter to wheel diameter ratio is given. So diameter of jet, that is small d, and diameter of wheel is capital D. So this is given 1/9, and next is given mechanical efficiency. Mechanical efficiency we can write this is 75%, or we can write this is 0.75. Okay, so these are the data given, and what we need to calculate? We need to calculate discharge required. So first one, discharge required, and second one is given diameter of the wheel. So diameter of the wheel is nothing but capital D, and third one is diameter of the jet, that is small d, and the number of jets are required, that is counts required, and number of jets. Along with this last one, this is fourth point, specific speed, that is ns. So these are the points need to be calculated. Calculate these points. Okay, so one by one we'll solve it. So first one, I'll do one thing here. If you see the speed ratio is given, from that we can find out the value of E1, because this value, if you multiply this one, we can calculate the value of E1. So anyway, I'll give the Q point actually. So we need to identify where this Q term is associated. So if you see the efficiency formula, there Q point is associated, because we know that one formula is there like overall efficiency. Here the power developed what is the power developed with respect to water power, or you can say the soft power by water power. So power developed is nothing but soft power that is given in our question. And water power value, if I write this one like this is the value given, and what is the water power value is nothing but, we know the formula for this, that is rho g q h divided by 1000. This is the formula for water power. Now if you see this terminology here, q term is involved here. So then remaining terms, this is density, this is gravity, h is given. Then one more value we need to identify, that is overall efficiency, and overall efficiency is not given, only hydraulic efficiency given and mechanical efficiency is given. Now if you remember one more terminology, like overall efficiency, we can write this is the multiplication of like hydraulic efficiency into mechanical efficiency. So in this terminology we can write and we can identify the value of overall efficiency. If you are able to calculate the overall efficiency, then we can find out the value of Q. Okay. Now overall efficiency equal to, this is hydraulic efficiency is given, this is 0.87 into this is 0.75. Then we can find out the value of this. So let me calculate. So this is 0.87 multiply 0.75. So this is 0.6525. So this is nothing but 0.6525. Okay, this is the value of overall efficiency. Now if I put the value of here, I can easily find out the value of Q. So here I can write the value of Q equal to this value, I'll take it to here. So Q, I'll take it to this side. So that means yeah, it will be come down. Now 1000 we can cancel here. This 1000 the density value we can cancel here. Remaining terms we can take it to, like, I'll keep it here. That means 8000. This is 8000 divided by G value is nothing but 9.81, and H is how much? 130. And next is this is efficiency value. Efficiency is how much is given? Overall efficiency, that is 0.6525. So this is 0.6525. Let's find out this Q value. So make it 0. This is 8000 divided by bracket start. This is 9.81 multiply 130 into 0.6525 bracket close, 9.61. So this is very less actually, but this is the Q value. Anyway, what are the value we got? We need to follow that. So 9.6138. So I can write here Q equal to, this is 9.614 meter cube per second. This is the unit. This is the discharge, okay, required, or discharge from the turbine. So this is the first point what we have calculated. It's easily identified. Now the second terminology, if you see what they asked, we need to calculate the diameter of the wheel. So diameter of the wheel, in formula we know that tangential velocity U1 equal to, we can write this is pi d n by 60. Now if you see this formula, U is unknown, pi is known, d is unknown, n is known. So U1 value we can, I told you already, we can calculate from here. So I can write this value like d equal to, in place of U1 what I'll put here, 0.46 root over of 2 into 9.81 into h. H is how much? 130. Okay, this is like U1 value, and into 60 divided by this is pi into 130. So let's do it again. Like what the values are there, make it 0. 2 into 9.81 into 130. Okay, this much root over of this. Again multiply this one with respect to 60 and 0.46. Okay, divided by bracket start pi into 130 bracket close, 3.413. So this is the value of diameter, 3.413. I hope it is correct. So anyway, what are the value we got here? Just we'll put the value here. Anyway, pi d n by 60. 60 is there, and 16 to E1. E1 value how much we got? That is most important here. So E1 is nothing but 0.46 given. I have multiplied this one, I hope. Yeah. This is nothing but, okay, let do it individual otherwise. Like first I'll calculate the E1 value. That is nothing but, I can say 2 into 9.81 into 130. Okay, this much root over of this, multiply how much is there, that is 0.46, so 23.23. okay, this is value same also we got in the last time, into 60, correct, and this, yeah, divided by bracket start, and here what will get, like divided by 60 into pi. Okay, here 60. Okay, so here if you see, actually n value is not 130. This is actually, yeah, this is here. This is the value of 200. Okay, that's why I thought why this slightly different values are coming here. Multiply 200, bracket close, 2.218. yeah, near about this one value will come, I know. So 2.22 I can say. This is our meter per second. This is the value of E1. No, this is the value of D. Okay, diameter, this much. The diameter means it will come only meter. Okay, so let's write here again. Diameter of this is 2.22 meter. I thought that was velocity. Anyway, this is also completed. Now the third one will calculate the third point, what is nothing but diameter of jet. So diameter of jet also, that is small d. So this one we can calculate from the ratio already given in our question. Okay, so the diameter of jet is diameter of jet, the d equal to, I can write from this equation, d equal to d by 9. So what I got the value, divided by 9 if I do, then I'll get the value of small d. So it will come very small, divided by 9, 0.246. So here if you see, this is 0.246 meter. This is our diameter of jet is required here. Now next we need to calculate the number of jets required. For that I need to calculate the area. For that I need to calculate area of jet. So area of jet equal to, I know that pi by 4 d square. So I can write this is area A equal to, because this formula will be required for to calculate the next step. That's why I'm calculating this one, pi by 4 d square. So this one we can calculate like this is the value, square of it. Again multiply it pi divided by 4, 0.047. So this one we can write, this is 0.0477, let it write this much meter square. Okay, this is the area of jet. Now from this we can calculate the velocity of jet. The velocity of jet formula, we know that this is nothing but absolute velocity, v1. So v1 equal to, we know that cv into root over of 2gh. Now cv value already given, that is 0.98, and root over of 2gh is nothing but 9.81 into h value. H is head, this is 130. So here we'll get the value of v1. So let's find out, 2 into, as I told you, 2 into 9.81 into 130. How much we got? Root over of this one, yeah, 50.50. Same thing, point into 0.98, 49.49. So this one I got, this is 49.49. This is meter per second. This is the velocity of jet. Now we need to calculate the number of jets. That's why I have identified this one. So let me write the discharge through the, because let me tell you, the number of jets, actually the formula is for this, if you remember this one, previously also I told you that total discharge, this is nothing but the total discharge, how much, divided by, we need to identify the discharge through jets. Discharge through jets. That's why I have calculated the area of jets and what is the discharge through one single jet. Now we need to find out this one, discharge through single jet, actually this one. So we need to find out now this second term denominator, that is discharge through the single jet. Discharge through the single jet is nothing but, we can write the same formula like AV we can write, and from AV we can write, this is suppose AV1 is there. Now here I can write the value of area, just now we have calculated. So yeah, area what we got here, yeah, this one 0.0477. so same thing I'll write here, this is 0.0476 suppose, and velocity just now I have calculated 49.49. so if I multiply this one, I will get it the value. So this is 0.0476, 2.35. so here I got the value 2.35, suppose 6 is there, and this is the discharge through jet, one jet, so that is this much meter cube per second. Now I can put the value here. So again let me write here, the number of jets equal to q value, total discharge is q, actually q already we have calculated here, that is 9.614. so the total discharge is 9.614. This is individual discharge through the jets, so you can calculate how many jets required from that. So this is 2. Okay, so if I divide this one near about 4, it will come near about 4 only, because 2.3 is there, multiply 4, now we will get 8 into 1.2, so 9.6 about something will get, so near about 4, that means 4 number of jets are required. And the last one, we need to calculate the specific speed. So specific speed, that is denoted by ns, and this one we have derived in our last lecture. The formula what we got there, that is n into root over of p divided by h to the power 5 by 4. So this one we can do in this way also, like just multiply, this is n is given 200 and power already given, that is 8000, and this is divided by 130 to the power 5 by 4. This is the value. So now we'll calculate one by one. Let me solve it in this way, like suppose 8000 is there and root over of this, so 89 point something is there, this is multiply 200, so how much will get? 17,888, 17,888 point something I got, suppose 5, and 130 to the power 5 by 4. Now this one divided by how much is given? 130 and to the power 1.25, let me write 1.25 bracket close, this is 438.96, 438.96 I can write 438.96. if I divide this one, then how much I got there? 40.75. so this is the specific speed, 40.75 specific speed. Okay, so this is the answer for this one. So, and what are the formula we have used, that is most important. We need to remember these things, formulas, so that we can easily solve the problem. The thing is that here the specific speed also, why it is required? To identify which kind of turbine. If sometimes the question will be given, normal question will be given, and it will be given that find out what kind of turbine it is used, or what kind of turbine was required for this kind of data. So though it is given here, but from the specific speed also we can identify which kind of turbine it is. So because in the specification of turbine, I told in the last video lecture how to identify or based on the values. So these are the formula which is helped to solve this one, and we need to remember this formula also. And this is one more also, like overall efficiency. So I hope you understand this problem, how to solve it. If you're having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you all.